Hello guys, welcome back to this new video, and today is another day of another ADHD coding project. I have so many projects in my mind, and today I want to start learning Zig. And I have a very cool idea, I guess, for a project that might be an interesting coding project to learn Zig, but also in general something that can be useful for students especially. But let's see what is that I want to build and how. So my idea is that when I was following some lectures from my professors, I realized that sometimes they were just too slow. Most of them, they were doing like a lot, adding lot of minutes of no extra informations, or somebody from the students were asking some very stupid questions. As I was saying here, like some questions were actually clever, but others were just from people who were not paying attention. So that added extra minutes to the lecture. Or sometimes the examples were just very simple and they could be cut. So the result is that a video which could take 1 hour, it takes actually 2 hours. So if I want to review a lecture, I have to review a 2 hours lecture, which includes a lot of these useless parts which do not add any information. So I just thought, okay, we can actually cut these extra parts. But how do you do this? What is usually being done by apps is that you can cut silences, or maybe also remove these elements, or that's it basically. You can just use AI to crop parts where there is no speech. But how do you actively cut out parts which have speech from the professor but which are actually useless? Well, there is some way, in my opinion, and it is by using some local LLMs. We can use some powerful speech-to-text models that can translate the video to some kind of speech, and then use another local AI model to understand which parts can be kept, which not, and create some sort of pipeline that selects only the most meaningful sections of the videos. So for example, if one section is flagged as superficial, it can be removed. So I think it can really work. In the end, I don't know, but we can try. So here I have a notebook in which I sketched some diagram of how the code could be made. So now I will just copy and paste it. I can't copy and paste from a notebook to my laptop, but I will try to recreate it here. So let's say we have a video lecture. Okay, and this is in some it's in some format which, I don't know, it can be, for example, mp4. Okay, it can be also maybe in .mkv. And something else. It's not really that important right now. So we have these lectures, and we want this lecture as a duration. So for example, here we can say that the duration is 2 hours. Okay. What I want is to reach a state in which we have the same format. Let's call it optimized video lecture. We have the same formats but a much lower duration, which we can say much lower than 2 hours. So we need to figure out a set of operations here that can make this lecture shorter. So I try to think about some of these operations that can be done, and I will write them here now, even though they might be just temporary. Maybe I will figure out something better, or like one block which I identified will be split into different blocks or something else, but that's not really important right now. It is just a starting point. So I need some way to extract only let's actually call it an extract block. What this does is, from here we take the MP4, the final MP4, or just the video actually, and another part just extracts the voice. So actually not the voice, but the entire audio. So we need a block that can extract just an MP3. I'm now writing MP3, MP4, but we need to see if that actually makes sense later. But what I want from this is only audio. I will actually write it like video, and here audio. Yes. So after we have extracted some kind of MP3 file, maybe I can just do like this. Wait a second. I like this. No, it's too small. Okay, let's use this. Okay, so here we have an MP3 file, and here like an MP4, let's say. Nice. So once we have that, I need to put this audio somewhere. We could actually... okay, it's fine. So we might create another block, which I will call speech to text plus timestamping. So this speech to text block takes an AI model, which I'm going to take from here, and we can write that this is an open source speech to text model. I think we can try to see if we can use no, I don't remember now the name, but there should be some local AI model that can be used here. And no, yes, okay, so the mp3 flows here and we get some kind of dialog file from here. So I can actually write it like this. So this is a dialog file plus timestamps, and it is in .txt, or yeah, .txt should be right actually. Okay. Yikes. So we have this dialog file. Actually, let me do. Okay. And what can we do now is take this dialog file, put it into this block, which I call the enricher. I don't know if that's even a word, but I think it's fine. And take the dialog file and the starting like the original video. No, not from here. From here. Okay. So what the enricher does, is taking the dialog file, which is timestamped and contains like what the professor, for example, is saying and any other stuff. It takes like another AI model that enriches the text. So it can extract some information. For example, it can start to do some pre-processing about which sections are more or less important, and which may be a bit more useless. And it's actually unclear right now what this block should do, but in some way it should produce a richer version of this txt that contains a structured view on the lecture and about which sections could be more important than others. So this outputs a rich dialogue, let's say. And it's in .md or maybe something else, but I think the markdown file is actually pretty good in this, but we may see if something else makes more sense. what else? So we have this rich dialog, and this enricher, of course, is taking. Let me actually do this. No. Okay, so here we have a general purpose local LLM. Which directly plugs it here. And this is basically the engine of this enricher, okay? Can I do? Okay. So, once we have that, we have a rich dialog, and I guess we can have like some sort of flagger, which takes this rich dialog, and it also takes some user input, like for example from the application console. So like about user input, about how aggressive should the flagger work. Like, do we have to cut a lot of parts? Do we have to cut like just silences, or just remove every example, or just some of them? So here we have some options. For example, we have like the aggressive option, we have the medium, and we have the low. Can we please get this for all? Oh my gosh, no, for all the text. Okay, or maybe actually let's get yes. So the flagger does that, and it creates another MD file, which we are going to call flagged dialog. And it's still in is this dialog? My English is bad, I'm sorry. Okay, so I guess it's fine. Okay, great. Yes, so no, sorry, I didn't have to do this. We are not done yet, because after we have flagged our like dialog for the parts that needs to be cut, we have the actual stage where the cut is performed. And only after that, of course, this cut needs this flag dialog, but it also needs again this MP4. So let me take, do we have dot? Yes, there is a dot. I want it white. Okay. No. What is happening? What is happening? Okay. So from here we have another arrow that goes in here. Okay, and then we're done. So looks like we have an idea, an overview of what the code should do. I'm really excited actually to start. Let me save that. I still don't know how this code is going to be called, like this application is going to be called. So for now I'm just gonna call it Zig and I'm gonna put it in my drive. But before doing that, I will download it. Where is it? Export as I guess PNG. Do I want a transparent background? I have no idea. Page diagram. Let's try. I wanna download it. Thanks. Okay. Let me see if I can actually add it here. Well, it's not working really well. So let me actually change the style. I don't know why we are like in dark mode. Page setup. Okay, this is really annoying. Page setup. Is it this one? Okay, better. It looks a bit ugly, but to be honest, it's fine for now. Let me remove the grid. I don't want the grid. I need to use the grid. No, actually I want the grid. So let's try to download it now. Okay. Okay, much better. even if it's not perfect, but I need more space in here. I don't know actually that is done. Okay. Okay, for now I will keep it like that. So we have a first starting point of what we want to do. So okay, great. Let me go back to dark mode because I'm getting blinded by the light. Okay, great. Then we can start working on it. So let me fetch the latest changes. Okay, so I don't know anything of Zig, like zero. I know other languages, other system languages like C, C++, and Rust, more or less. So I think I can learn quite fast, but I will use AI heavily to do this by a concept that I tried in my last project, and which is by creating a custom plan to learn Zig made by the AI. So I'm using Codex right now. Let me open Codex. And so what I want him to do, give me a second. I'm actually having some doubts now. Like, should I first validate this? Yes, let me validate actually this design first. So, hello. I want to make a console application, because it's going to be a console application in Zig. And it's going to be my first app in Zig. What I want... Wait, let me drink a bit. So, what I want to build is a pipeline. Is an app that turns a boring long lecture, actually let's write uni lecture, 2+ hours, into a short and detailed one with more or less the same information, but less useless content, like professor silences and amps, useless, not very informative examples, and extras. So read me to have a more detailed understanding of what I want to build, and get also also look at the following image diagram, actually, which describes the blocks of how I conceived the application. Once you're done, please review my implementation idea and give me some constructive feedback. Can be both positive or negative. I write this extra line because if you don't write it, maybe they are very like they will try to make you happy. So if you don't tell it that it can also be negative, they may only give positive feedback, which I do not want. I mean, it's fine, but I also need some negative feedback. Just do that, and I will tell you later for the next steps. So let's see what we get. I've used GPT 5.4 High because I think it's like good enough for this task. Oh fuck, I forgot about the image. Okay, sorry. Forgot about the image. Here it is. Ah, that's strange. How can I image? Yes. Let's see what we get. Okay, so your pipeline is directionally good. Media solid through the lecture as a sequence of timestamp semantic segments. Score them, then cut the original video accordingly. The flow is decomposed into clear stages: extract, transcribe, enrich, flag, cut. You're keeping timestamps early. This is the right foundation for video editing later. Strong plugin, okay. Training models locally makes sense. TXT and MD are weak intermediate formats. Use a structured format instead, ideally JSON. Yeah, maybe he's right. So we might switch to JSON. I've never used JSON actually in my projects because I'm more of an hardware engineer, but it may make sense, to be honest. What is this shit? Okay. Why is it so big? Oh my gosh. Okay, whatever. Yeah, this is standard JSON. So we got fields, and they can be nested. So a field can nest other fields. Okay. Yeah, it makes sense, I guess. number, signed decimal number that may contain a fractional part and may use exponential e notation. Okay, string, boolean, array. Order a list of 0 or more elements, each of which may be of any type. So you can, like, arrays can be of mixed types. Object, a collection of name value pairs where the names are strings. Objects are delimited with curly brackets. Okay. What space is allowed and ignored? Okay, great. We can use JSON. So here this one becomes a .json, and also this one. Let's remember later to update it. Also this one. I mean, I prefer not to use JSON because it could become a bit more like less straightforward in my opinion. Because like if I have a txt like which is timestamped, I could just write, like, for example, I don't know, second, like 1.1 hello, this is a lecture, this is a lecture, then we have seconds like 345.5, this is a number, yeah, something like that, but not sure for now. We can also keep a JSON. The enricher is the riskiest part. A general purpose LLM can easily hallucinate missing meaning, paraphrase too aggressively, lose alignment with timestamps, remove context that was actually important. For cutting video, the source of truth must remain the original transcript segments, not a rewritten document. Okay. Yes, should classify questions, that's true. Transcript data, this is function and timestamp anchored, generated by STT, which I don't know what that is. Semantic annotations, this is what the AI thinks about each segment. Filler, silence, repetition of topic, okay. Then the cut stage should operate on original timestamps, annotation scores, and editing heuristics, not on rewritten markdown. Ah, okay, he's right. So what he's saying is that if I just directly feed here the timestamps and then just forget about it, I'm going to get this rich dialogue, which is still timestamped, but they can all be hallucinated, and it probably will be. So that's not a good idea. It's a good idea to still have the timestamps here, which are directly going into here. Let me do this. I'm not sure if we also need it here. Um, transcript data and semantic annotations. Yes, exactly. Yes, and okay. The cut stage should operate on original timestamps, annotation scores, and editing heuristics. Yes. Extract audio. Okay, we can use ffmpeg. I was actually thinking of using that. So we can actually write this here. Run VAD silence detection first. That is also right. That is also very right, yes. Transcripts run STT with word or segment timestamps. Okay, so here let's restructure it a bit. So before doing this timestamp, we can actually have something. We can oh my gosh, it's a mess. I need to like move everything. Can I do this? Is it going to mess up everything? I hope not. It kinda didn't. Okay. So here we can have another block, which is the silence. Oh my gosh, what is happening? Silence remover. I want this block to be optional. Maybe based on what happened here. Oh my gosh, this goes in here. Let's remove this one. Yes. Okay. Great. So we have this this block that removes the silences optionally, maybe based on this user input. I can write it. Like on how aggressive the algo is. Okay. Great. bring this in here. This one we can put it here. Okay, great. Okay. Let me see. Run speech to text. This is called STT, not where is it? I remember writing like speech to text as here. STT. Okay. Stores transcripts in structured JSON, chunk transcripts into semantic segments, run LLM annotation on chunks, score each segment for keep versus cut, apply aggressiveness policy, merge neighboring capped segments with padding. Yes, true. Cut original video with FFmpeg. Yes. Output final video. Yes. Use FFmpeg for extraction. Use an STT engine like Whisper or Faster Whisper. Okay. Consider to remove the silences before SST. Support speaker diarization. I don't know what that is. For first Zig app, this is important. Do not try to implement the machine learning part in Zig. Why? What do you mean? CLI interface, config parsing, pipeline orchestration, process spawning, file management, intermediate data handling. Let external tools do the heavy work. For FFmpeg, STT executable, local LLM executable server. Yes. Good segmentation, good scoring, conservative identity rules. Okay, great. Let me download this new actually, let me tell you. This doesn't look that bad, or maybe yes, it does. Now let's keep it like this for now. So download it. I mean, actually, let's save. Already saved or not? Okay, let's download it. Let's change it here also. Great. And let's ask him, I have updated the diagram. Check now if it makes more sense. The biggest improvement is that you move from TXT to MD JSON and separate the raw transcript data and enrich semantic data and flag cut decisions. Okay, what is better? JSON as the intermediate format is the right choice. Cut stage now receives both original dialog plus timestamps. Flagged enriched decision, this is correct because cutting should still anchor the original timings. Making silence removal option is sensible. Explicit naming Okay, the problem now looks close to an actual implementation. What is still unclear? The role of Reacher. Right now it seems to take transcript JSON, local LLM, and original video. Yes, the Reacher doesn't need the original video. That is true. Because right now we are going to operate. What happened here? Oh my gosh. No. God's sake. No, this is not what should happen. What? Okay. Yeah, we don't need it in the enricher because this is just going to operate on timestamps, and it's just the cut stage which takes care of cutting the video with the MP4. Yes. Transcription timestamps may be metadata. Only pass video derived data if you explicitly plan to use slide change detection, visual context, screen text, word writing changes. Okay. If silence removal happens before STT, you reduce transcription cost time, but you also alter timestamps relative to original video. That means you must be careful. If STT runs on silence streamed audio, the timestamps will no longer match the source video unless you keep a mapping table. So you have two clean options: run STT on the original extracted audio and use silence detection only as a notational signal. Okay, didn't actually understand very much this part. So basically what could happen is that the speech to text will be timestamped, but this timestamping, since you already removed the silence, is going to be it's going to drift away from the timestamps in the real video. So either we map it in some way, like the new timestamps to the old ones, or we move the silence remover thing. What does it mean to use silence detection only as an annotational signal? Also, flagger versus enricher. The distinction is mostly good, but you should define it sharply. Enricher annotates what each segment is, and the flagger decides keep cut given aggressiveness. Okay, that makes sense actually. That's right. So this I forgot. Annotate what each segment is. And the flagger, decide keep cut given aggressiveness policy. Okay. So transcript, for example, contains segment ID, start and time, text, confidence, speaker if available. Annotations.json contains segment ID, labels like filler, definition, example, repetition, question, important, scores, confidence, explanation. Okay. Edit plan.json contains keep cut decision, aggressiveness applied score, final cut intervals, padding, merge info. Then cut consumes the original video and this edit plan.json. And the annotations. I guess the transcript. This is cleaner than sending multiple partially overlapping JSON files around. Yeah, we need to define some tags that can help the LLM understand which features are actually cool. Okay, let's understand this timestamp alignment. Should I just pre-cut the video question level and do silence removal, but only as soon on the mp4 .mp4 so that misalignment cannot happen. It makes sense, yes. Not as primary strategy. If you pre-cut the mp4 early based on aggression, you create a harder problem. You need semantic decisions before you have reliable transcript analysis. Why? The silence cut mp4 becomes the new source of truth. So where is the issue? When this is valid, original lecture video, remove silences from video, audio, save trimmed mp4. Okay. Reversibility. If silence removal is too aggressive, all later stages inherit that mistake. But that happens anyway. Harder tuning. If the user changes silence sensitivity, you must regenerate the canonical media and rerun everything downstream. Yeah, I mean, silence removal can be conservative, and we can just decide to make it not too aggressive. Make silence removal optional, conservative, separately configurable from semantic aggressiveness. Yeah, of course. Do not tie silent streaming directly to low, medium, aggressive. Yeah. So he's not really agreeing with me for this, but I think it can actually make sense, because what if why do we need to keep this alignment when we can just perform the removal later? I mean earlier, since we need to do it anyway. There is really no difference. So let me do this. So before extracting, okay. Here we get still an MP4. Okay. I think this is very good. It's like a final plan. Yeah. I like it. Great. So Let me download again. Export as PNG. Let's also save it. Okay. Great. Yes. Commit changes. So let's see. Actually, let's do a git pull again. Change again the diagram. Watch now. And Richard and Flacker have clearly different jobs. Cat still uses okay, so it's explicit. If the silence removed data is the input to extract, then the timeline is entirely consistent. Yes. The main thing I will still tighten. Right now, the diagram we should suggest that the same user aggressiveness level may control both silence removal and semantic cut policy. Where? Ah, yeah. Okay. Sure. Okay, sure. So, yeah, it makes sense. It's just complaining that this shouldn't be really coupled to the aggressiveness level because they're operating on two different dimensions, let's say. Silence removal policy, let's say. Okay. Define the constructor for each stage. Speech to text output. Not now. Yeah, we could do that actually. Yeah, I also thought about calling this annotator actually, and it makes more sense. And the flagger selector or policy engine is a flagger. Sorry. Policy engine is not bad. Or selector. We can call it selector. Okay, great. So I think for today is it's done. We have a clear pipeline of what I want the code to do. I know we didn't write any code in here, not Zeke. But in my opinion, this is necessary if you want to build like an app which you know what it you want it to do before actually coding it. I might actually next time do another design of what the AI was suggesting, so like a contracts between these fields, sorry, these blocks. So for example, yeah, what should the lecture pass to the silence remover? The MP4, and that's it, I guess. But for example, from here to I'm not sure, actually. I can just do that in code. I don't want to over optimize it, over analyze it. I think this is a good starting point, and we can just implement from here. Since I modified another time, I will download it another time, and I will also save it, and here I'm going to upload a new version. Okay. By the way, this repo is not public yet, because I want to reach like a stable version before I put it public, and I also have to choose a name. But yeah, other than that, I think it's a cool project, and I will be happy to work on it. As you may see, I start lots of projects, and yeah, that's really part of my brain. But yeah, hopefully I will finish some of them. So that's all from TechMat, and it was really nice. I'll see you in the next video. Bye bye.